This is why your cat isn't living in multiple states at once. In the quantum world, tiny particles like electrons can exist in multiple states at the same time, a phenomenon called superposition. But why don't we see this in everyday life? First, particles remain in superposition only if they are perfectly isolated. But in reality, objects interact with their surroundings: air molecules, light, heat, and even radiation. This interaction acts like a continuous measurement. Any quantum effects are destroyed in an unimaginably short time, far quicker than we can notice. Second, the warmer an object is, the more its atoms jiggle and interact, which further speeds up decoherence. Microscopic quantum systems are usually studied in ultra-cold environments, close to absolute zero, to keep them from interacting with their surroundings. But everyday objects exist in normal temperatures, where superposition cannot survive. Thirdly, the observer effect, measuring a system collapses its superposition into a definite state. While microscopic particles can be kept unobserved in experiments, macroscopic objects are constantly being measured by their surroundings. Even the simple act of light bouncing off an object and entering your eyes is enough to destroy any quantum superposition. Lastly, a fundamental principle of quantum mechanics is that its effects become less noticeable as objects get larger. The reason? The ratio between an object's action and Planck's constant determines how quantum it behaves. For tiny particles like electrons, this ratio is small, so quantum effects dominate. But for a cat, the ratio is astronomically large, making quantum superposition practically invisible. So, can we see macroscopic superposition? Scientists are trying. Researchers have created quantum superposition in tiny mechanical systems, such as superconducting circuits and nanoscale vibrating membranes at extremely low temperatures. However, these objects are still much smaller than visible objects. Quantum superposition is real, but it's fragile. For microscopic particles, it lasts long enough to observe. For larger objects, the environment, heat, and constant interactions destroy it almost instantly, forcing the world to appear classical. Quantum weirdness belongs to the microscopic world.